Hello class, I wanted to walk you through our inclined tube manometer problem from lecture. You've got a slide like this in your course pack on the pressure measurement section. Here we've got two layered fluids on the left with given specific gravities, points labeled at A between the two fluids where their interface exists, and pressure B in a sealed vessel containing air, and given a pressure differential and a known measurement along the manometer, the question here is what is theta, the angle of that inclined tube manometer shown in orange on your slide. So our approach to this problem is going to be to apply our hydrostatic equation to relate points A and points B. Note specifically that we don't have to start at the atmosphere, so at the surface of fluid 1. We can start working from any point that we want to, so long as we're continuous about our movements in the horizontal, which does not change fluid pressure, and in the vertical, where we do see pressures changing proportionally to the specific weight of the fluid. And so in this case, we can write our manometer equation looking something like this: the pressure at B equal to the pressure at A plus H2 times gamma 2, so we're moving down from point A to the bottom of the container in this case. H3 gamma 2, that's moving back up through the inclined tube manometer where the green fluid exists, and then we're moving up through the air, distance of H air, the vertical distance we move through that fluid. We know something better about H3 because this is a right triangle. We can use the sine of theta to relate the hypotenuse to the opposite side. And so for H3 we can instead substitute L3 times the sine of angle theta. We can further simplify the problem by assuming that the air provides a negligible amount of hydrostatic pressure change. That's an assumption that we've discussed a few times in class as well as in the textbook. And so with those assumptions, we're left with the equation that I've written on the slide here. We can go ahead and rearrange this equation, and I've done two things in this rearrangement. The first is that I've moved the pressure at B to the right-hand side of the equation, so we now have pressure at A minus pressure at B. I did that because that's a given quantity in the problem. And then I grouped terms on the right-hand side to get that specific weight of the green fluid grouped outside of those terms. That's just my preference to try and group things together when I can. You certainly don't need to. Now, substituting values given for the variables that we've calculated and running out of room, putting the 62.4 pounds per cubic foot on the next line that's multiplied by the quantity in parentheses. You've got a solvable equation now, so one equation and one unknown. You can solve that for theta, and I end up calculating a theta of about 34 degrees for this problem. Please try this problem on your own and be prepared to work through these in class or on a quiz. Thank you.